Hello, today's video is going to be on graphing general rational functions. If you don't have your calculators out yet, go ahead and push pause and go get them. So we're going to start off by reviewing simple rational functions, which we have already gone over a few days. The first one is if I have y equals a over x minus h plus k. If you remember, this right here is one of your asymptotes, and k could be 0. So if there is no number being added outside, it could be 0. A on the top is just a constant, and we have x to the first degree on the bottom. This means that the higher degree is on the bottom of the equation. For our other one that we looked at, I see that I have a first degree on top and a first degree on the bottom. This is when we have the same degree on top and bottom. Those are the two equations that we've already looked at. Today we have a new one, a new form, and that is when we have some p of x over q of x. P of x and q of x could be different higher degree polynomials. So it's not necessarily going to be a linear. It could be a quadratic. It could be a cubic. And this is just a fancy way of saying it could basically be any degree we want on top and any degree on the bottom. For all three of these, so the two that we're reviewing and the new one, we are going to find the vertical asymptote the same way for every single one of these three different forms. The VA, which is the vertical asymptote, we find that by setting the denominator equal to 0. And then, of course, we solve once we set it equal to 0. The HA, the horizontal asymptote, is going to be a little bit more difficult. Each situation is going to have its own set of rules. So regardless of which of the three equations you had, the vertical will always be setting the denominator equal to 0. For the horizontal asymptote, if I have the same degree top and bottom, that's one of the ones that we reviewed, no matter if it's a first degree or second degree, but if it's the same degree top and bottom, you are going to divide the leading coefficients. So that horizontal asymptote is going to be y equals a sub m over b sub n. And again, that's just a fancy way of saying divide leading coefficients. So that is if we have the same degree on top and bottom, we divide the leading coefficients. If the higher degree is on top, so it's either the same or the degrees on higher degrees on top or bottom. Actually, let's do bottom first because we know that one. So if the higher degree is on the bottom, this is the other one we're reviewing, we have a horizontal asymptote at y equals the number being added outside the fraction. In the above equation, that's the k value, and as we mentioned above, if no number is being added, it could just be 0. Now for the new equation. If the higher degree is on top, there's no horizontal asymptote. So that's going to sum up all of our equations, the old ones and the new one. This is what you do in every single situation. So you want to make sure that you have this handy, you have notes taken really well on this, and you always refer back to this little section right here. This is really important. This summarizes all of our different equations. Now we are going to look at some examples. Our first example is y equals 4 divided by x squared plus 1. The vertical asymptote. Again, if we're not sure, we refer back to our chart we just made. The vertical asymptote is set the denominator equal to 0. The denominator is the bottom of our fraction. So we have x squared plus 1 equal to 0. We move that 1 over, we get a negative 1, we take the square root, we get plus or minus I. I is imaginary. We can't see imaginary pieces on our graph. So we do not have a vertical asymptote. The horizontal asymptote, we look at our equation. I see a constant on the top. I see a second degree on the bottom. That means the higher degree is on the bottom. And I refer back to my rules. If the higher degree is on the bottom, this is our middle one right here, we are looking at the number that is being added outside of the fraction. I look at the number being added outside my fraction, there is no number, which means it's a 0. Therefore, the horizontal asymptote is y equals 0. Our domain and range. Let's go ahead and graph this and then start talking about our domain and range. This is why we needed our calculators out. We go to our y equals. We type in our equation. Yes, you may have that fancy fraction button. Remember the alpha y equals. Number 1 would let you enter this in as a fraction. But I like to see decimals, so I don't do that. So we have y equals. This is 4 divided by, we have x squared plus 1. That's the entire thing on the bottom of the fraction. So I need to make sure that I put that in parentheses. X squared plus 1. Again, make sure that you have the denominator of your fraction in parentheses so that your calculator does all these calculations correctly. We go to zoom 6 to make sure that we have a 10 by 10 grid. And there is our graph. A little bit different of a shape than we've seen. We go to our table of values to get points. So that's second graph. And we can see, oh, there's our maximum point right there at 0, 4. Negative 1, 2 on the left, 1, 2. So if I look back at the graph here, this right here is the maximum at 0, 4. So if I have a max at 0, 4, I'm going to do a couple points to the right and a couple points to the left. Can I get that from my table of values? Second graph. So 1, 2, 2.8, and 3.4. On the other side, negative 1, 2, negative 2.8. So I'm using these points right here in the middle. I'm always going to list out the coordinates of the points that I'm using. I do look for this on assessment, so make sure that you list the points. So again, I had the maximum, then the point at 1, 2, 2.8, 3.4. Same thing on the other side. Negative 1, 2, negative 2.8, and negative 3.4. We double check of what we had. We had no vertical asymptote. I see that. I did have a horizontal asymptote at 0. So there's my dashed line showing my horizontal asymptote, and that is supporting the graph that we found in our calculator. I can see that my graph is approaching that line, but never touching. So my domain, my graph is forever going to the left and forever going to the right. The domain is going to be all real numbers. The range is my movement going up and going down. It doesn't exist below my asymptote, and it actually doesn't exist everywhere up. Right here, this is the highest my point, my graph is going to get. My graph is only existing between these sections. The highest point is at 4, all the way down to 0. Now, 0 is the asymptote, so I cannot include 0. 4 is a point, so it is less than or equal to 4. My graph is existing everywhere between 0 and 4. It does not include 0, but it does include the 4. All right, let's turn over to the next page for our next graph. Number 2, our vertical asymptote. Remember, we set the denominator equal to 0, x squared minus 4 equals 0, and we solve. We have plus or minus 2. Oh, that means I am going to have two asymptotes. One at 2 and one at a negative 2. Go ahead and put those on my graph before I forget. A vertical asymptote at a negative 2 and a vertical asymptote at a positive 2. I do every vertical asymptote the same way. I set the bottom of my fraction equal to 0. Then my horizontal asymptote is all about the degrees. I see that I have the same degree top and bottom. Same degree top and bottom. So I'm going to divide the leading coefficients. That is where you have the 3x squared over the 1x squared. So it's 3 divided by 1. My horizontal asymptote is at y equals 3. I put that. And then we go to our calculator. We go back to our y equals. We clear out what we had. I have 3x squared divided by, again on the bottom of my fraction I have that entire piece of x squared minus 4. So I have to put parentheses x squared minus 4, close parentheses. Make sure that if you have more than one piece on top, more than one piece on the bottom, that you do put it in parentheses. We hit graph, and we see this funky little shape, and that kind of supports what we see. We have asymptote over here, asymptote here in the middle. We have 3 sections to our graph. When we graph this, we get those points from second graph. We go to our table. See where those error messages are coming in? The error messages are there because we have asymptotes. That negative 2, that positive 2. Otherwise, I'm going to be scrolling up and down to find the good points that I want. On this left section, I'm going to use the point negative 3, 5.4. Again, I found this in the table. Negative 4, 4, and negative 5, 3.6. Why did I choose those points? My asymptote's at negative 2, so I go to the next point over, which is negative 3, 5.4, and then negative 4, 4, negative 5, 3.6. I'm using just the next consecutive pieces. So when I'm in this middle section, the asymptote's at negative 2, so I'm going to choose my point at negative 1. And at negative 1, I'm at negative 1, 0, 0, 1, 1. I plot those points. There's the middle section of my graph. And then we move over to the third section. My asymptote's at 2, so my next point's going to be at 3, 5.4, 4, 4, and 5, 3.6. Plot my points. And there are the 3 sections of my graph. Remember, the domain is directly related to the vertical asymptote. As I'm going left and right, it's everything, all reals, except x cannot be equal to a negative 2, because I have an asymptote there, and it cannot be equal to a positive 2. I'll go ahead and write that separate, because of the asymptote on the right. Our range, as we are moving up and down on our graph, it does not exist at 3 because I have that asymptote. And it actually doesn't exist all in here either. My graph is existing everywhere below that 0. So when we write it this way, it's all reals. Y has to be less than or equal to 0, because that's that middle section of the graph. And then it's existing above 3, because 3 is our asymptote. All right, we've got one more to go. Our vertical asymptote, we set the bottom equal to 0, giving us a vertical asymptote at 2. We plot that on our graph. The horizontal asymptote, we look at our degree. I have x squared over x, That means that the higher degree is on top. When the higher degree is on top, there is no horizontal asymptote. What I want you to do, actually, let's enter this into our equation together. So we hit y equals, clear that out. I have all of that in my numerator. So parentheses, x squared minus 2x minus 3, close parentheses. I put everything from my numerator on top, divided by x minus 2 in parentheses on the bottom. You hit graph, you see what it is. What I want you to do is find your own points and complete the domain and range. Push pause right now, do that work, and then when you're done, push play and check your answers. All right, let's see how you did. These were the 3 points I used on the left. These were the 3 points I used on the right. Remember, I based it on the asymptote. Since the asymptote is at 2, I used 1, 0, -1, and then 3, 4, 5. My domain, as I'm moving left and right, it forever goes to the left and it forever goes to the right, with the exception of the asymptote in the middle at 2. That's why it's all reals except for 2. My range, my arrows are forever going up, forever going down. There's nothing stopping that vertical movement because there's no horizontal asymptote. So that's going to be all real numbers. All right, that's it.